Okay. And so, as I said, this is going to bring us up to the chapter on star formation and also evolution, which we're going to see what that means in a moment. So this title slide is basically showing you an interstellar nebula, which we're going to talk about in a lot more detail. So generically speaking, we refer to all the stuff between the stars that isn't nothingness as the interstellar medium. Okay, so as you already know, there's a lot of empty space in the universe, but there's also space that's filled with very low density clouds of gas and dust. And that material we just generically refer to as the interstellar medium. And medium is kind of a word borrowed from physics, right? So if you've ever talked about, optics or the way light travels through things, or even sound, we'll talk about the different media through which a wave propagates. So that's why it's just called, basically it just means material. So it's the material, whatever it exists between the stars. Okay. Whoops. Why is it not going? Oh, because it's yelling at me. Okay. Not. All right, there we go. Okay, so in your book it says, well, if you want to see the dust that we're talking about and how it's patchy and cloudy, then just drive away from the city lights and lay yourself back and stare up at the sky, and you'll see the band of the Milky Way. In actuality, that's a lot harder to do than you think, right? Light pollution is a big problem, especially in the eastern portion of the United States. And I don't know about you guys, but even when I've been to relatively secluded places, I've never been able to really see much detail in terms of the Milky Way. Has anybody seen that? A band across the sky? I mean, the closest I think I can imagine is when I was out at Lake Raystown, kind of in the middle of Pennsylvania, and it was clear there, so you could kind of make out that there was a band there, but you're not going to see anything like this, and much less be able to really detect the patchiness of it. So I think if you have the luxury of maybe living in the desert Southwest and then driving away from the city lights, maybe you could see it, but around here, I don't know that you'll be able to see it. But thankfully, we have a lot of telescopic images that we can draw upon to get an idea of what this thing looks like. And of course, in ancient times, this is what people would have seen with their naked eye every night. But, we just have to go on telescopic images. So in any case, you'll either have to trust me or go by the images that we see here, that the disk of the Milky Way itself, which we haven't really talked a whole lot about the structure of the Milky Way, but suffice to say there's a disk to it, and within that disk is where most of the stars are. However, that's also where a lot of the dust and clouds and interstellar medium is, and so some of that light of distant stars is going to be obscured by the clouds of dust, right? The gas itself doesn't really do much in terms of blocking the light that we see, but the dust clouds do. And so the dust is comprised of tiny microscopic particles. You can kind of think of it as like when you're driving down the highway and some truck releases a bunch of smoky gas, you can kind of not see through it, right? It's like dusty, but made up of tiny little particles. So it's a similar idea, only now we're in outer space. And so if you look at the part that's in the white box here, we can blow that up and look a little closer. And you see that there are several regions that are identified here. The M goes back to the Messier catalog, which just kind of cataloged a bunch of fuzzy things that they saw. And so these just are not necessarily the same objects, but in this case, we are labeling some nebula, and they correspond to those catalog numbers. Okay, Here's another picture of something, one of these, M8, if you zoom in further, the Lagoon Nebula. Some of these are given whimsical names just based on what they subjectively seem to remind astronomers of. If you think about it, that's kind of in keeping with the tradition of naming constellations, right? We're just kind of, yeah, it's like looking at clouds in the sky and being like, yeah, I see a bear or an elephant or whatever. So it's a similar idea. This must have reminded somebody of a lagoon, so it was named the Lagoon Nebula. And we'll talk more about what these actually mean in a moment. The Trifid Nebula is actually really interesting. The image on the left here was taken at Mount Palomar. 1.5 meters, by the way, that's pretty large, right? That means that the lens on this thing, or the mirror on this thing, is 1.5 meters in diameter, right? So a meter is a little more than 3 feet. So, you're talking like 4.5, 5 feet, almost my height, right? As the diameter of your objective. So that's rather large. So we're seeing a lot of good detail here. The reason that this is called the Trifid Nebula, they're seeing like 3 basically lanes of dust, right? The prefix tri comes from 3, like a tricycle. So there are 3 lanes of dust here that obscure the light. And another example, M17, I think this was over here on that image. So M17 is named the Omega Nebula, and it's also got some neat colors to it. And then one of the more famous ones is the Eagle Nebula, which if we go back here, this is this one that's maybe not as bright looking, but when we zoom in on it, it's got this structure to it that I guess reminded people of an eagle. To me, I don't really see that, but they look like pillars to me. I guess maybe here you could kind of make out a wing of an eagle. I don't know. Do you guys see an eagle? I'm not really sure, but like I said, sometimes they're whimsical names. Here's a little bit of a closer look at that. I think these are called the pillars of something within the Eagle Nebula. Pillars of, I forget. There's a term for it. But, these are just basically 2 different images of that. And so nebula is kind of got a nebulous definition because it's not really, yes. You want to go back?
Creation.
Huh? Pillars of creation, okay. And the reason for that is, as we're going to see, oftentimes some nebula are associated with star formation. So it could be that stars are being created within these pillars, and thus the term pillars of creation. Anyhow, as I was saying, the term nebula is got somewhat of a nebulous, messy definition because it can refer to different things. It's generically just basically any fuzzy patch in the sky, generally some sort of collection of interstellar medium. But the nebula can behave in different ways. You can have something which is called a dark nebula, and essentially that's just a cloud of dust, and it's going to block out the light from the stars that would be behind it. And again, you could picture some smoggy truck going by and blocking your view of whatever would be through the dusty smoke. An emission nebula, on the other hand, is one that actually glows because there are hot stars near it, so it is emitting light. So that's where the term emission comes from. It emits light because it's glowing due to nearby hot stars that are warming it and causing it to glow. A reflection nebula, on the other hand, has to do with light rather than it being produced and glowing. It's light that's scattered by dust. And generally speaking, these are blue because blue is scattered preferentially by the molecules that the dust is made up of. And so you can kind of still see through them, so they're not quite as dark as a dark nebula, but they may scatter light from nearby stars. Okay. Oh, one other thing while I'm on this slide, I might as well mention the thing I was talking about in the book. And I thought maybe I had pictures of this in this talk, but maybe I don't. But anyway, on page 168 of your book, it says about dark nebula that, you know, it blocks out the light from the stars behind it. And, you know, then it shows beneath that, well, actually, if we look in infrared, we can see those stars a little better because the infrared is able to get through the dark nebula. But the problem was that prior to that, they say Barnard 68, almost a light year across, about 500 light years away. Its center, where the dust is the greatest, is opaque to all light. No. If it was opaque to all light, you wouldn't see it in the infrared either, right? Because all light means all the light that exists. What they mean is all visible light, right? We can't see it in the visible, but as we know, visible is just a very small portion of the electromagnetic spectrum, very small portion of all the light that exists. So it's silly to say that it's opaque to all light. It's only opaque to all visible light. So even though these dark clouds may obscure some stars behind them, if we look in other wavelengths, we can often at least see through them, maybe not clearly, but we can see through them a lot better than we can in visible. Okay, so as I said before, the interstellar medium, all of these nebula consist of two things, one which is gas and the other which is dust. Okay, gas, as we found, is mostly hydrogen. This should not be really surprising, hydrogen and helium, because in as we'll see when we talked about cosmology, when the universe was formed, it was basically entirely hydrogen and helium. And as stars have lived and died, they've produced other elements, but still the vast majority of the universe is made up of hydrogen and helium. So it's really no surprise that these clouds, this gas that's within these clouds, is also made up of primarily hydrogen and helium. Now, be careful here. I'm making a point that the gas is cold, and as I say, less than 100 Kelvin. And I think, like, in our minds, having grown up with Fahrenheit, or even if you grew up with Celsius, 100 sounds like actually really hot, but it's really cold, because in the Kelvin scale, 273 degrees is the freezing point. So you're talking more than 100 degrees below freezing, right? So this is a very cold kind of temperature. So gas that the medium consists of is, generally speaking, pretty cold, unless it's, you know, the glowing gas in an emission nebula. And it's also, like I said before, not very dense, very low density. Another word for that is diffuse. Okay, so and so, you know, you can see here the comparison of a true vacuum that we can produce on Earth, which is still not nothing, but, you know, it's very, very low density. And you see that these gas clouds are more dense than that, but nevertheless, that is still a very small number, so it's very low density. And then the other thing besides gas that makes up the interstellar medium is your dust. And as I said before, these are little tiny particles that basically can, usually molecules that can, you can kind of just think of them as dirt or dust that kind of can obscure the light. Okay, and here's a like zoomed in microscopic picture of what those dusts might look like or do look like. Generally speaking, we're looking at materials of carbon, silicon, heavier elements. We call them like dirty ice a lot of times. That terminology is also used to refer to comets as dirty ice balls. So, you know, you're looking at some molecules and heavier elements rather than hydrogen and helium. That's what distinguishes it basically from the gas. Okay, so now the dust in the interstellar medium can do two things. First of all, we've already talked about this phenomenon of extinction. Basically, that just means it's obscuring the light. It's absorbing the light, blocking the light, so that we cannot really see through it that well. The other effect that can happen is that it can cause the stars behind it or the objects behind it to appear redder. And so this reddening effect occurs because of the way the light is also scattered. So it's absorbed and it's scattered. And because blue is preferentially scattered away, then what actually gets through is less blue and more red. Okay? And so here's that image I was telling you about in your book where you can't really see through this dark nebula in visible light. See how it's this V is red in this image? That means that this image was taken in visible light, and you can't really see anything behind that dark nebula. But the image below, you see that the eye is highlighted in red, and that means this image was taken in infrared. And you can see now the stars that are behind there, but they're noticeably redder than the stars that are not behind the nebula, right? See, these ones don't appear quite as red as these ones that are behind the nebula. So those are two effects that are produced by these dust particles. Okay, here's another example of a dust cloud here. And here, this is again invisible, and then here is the same cloud again in radio with false color added to it. So any of these ones that are not in visible light are false color added. So same thing with radio. This is false color added, kind of showing you the contours of where it's the most dense, which it looks like the most dense region is right here. Okay. Yeah, so it's absorbing carbon monoxide here, basically. Another example of a nebula that is famous is this Horsehead Nebula. You may have seen this. This, I think, is a Hubble image. And you see it less zoomed in here and more zoomed in here. But it's, again, an example of a dark nebula where you can't really see the light behind the Horsehead. The reason you see it is because you've got all this glowing behind it, but you know, this dark patch kind of stands out because you can't really see what's behind that. Okay, then we move on. Instead of dark nebula, let's talk again about the second kind of nebula that you can have, which is an emission nebula. And as I said before, these things are basically glowing from the heat of nearby stars. So this Rosette Nebula here, I don't know, does it look like a rose to you? Can you imagine that? Maybe. Again, imaginative names. But anyway, the Rosette Nebula glows in a couple different colors. You see some red here and some green as well. And those different colors are, again, it's glowing from the heat of all these nearby stars, but the different colors correspond to different molecules. So the reddish hue you have here around the outside perimeter is from what we call H-alpha emission, which is essentially hydrogen. Okay, so the red indicates hydrogen, but the green, on the other hand, that is within here, is glowing because of oxygen. Okay, oxygen is reacting with the heat and light and giving off light. And then you also have a little bit of blue scattered in here too, and that's indicating sulfur. So this Rosette Nebula must be made up of some hydrogen, a lot of hydrogen, some oxygen, some sulfur, and it tells you a little bit then about the composition of those kind of things. Okay, so emission nebulae are interesting because they kind of confirm that these things are mostly made of hydrogen, but you've also got a smattering of other things like oxygen and sulfur that we can see from the other colors. And so that's the second type of nebula. We talked about dark nebula, emission nebula. The third type is the reflection nebula, where instead of really glowing in a sense, they're just scattering light from nearby stars. So you may or may not realize that the Pleiades, which is a fairly famous cluster of stars, is surrounded by a reflection nebula, and it kind of glows blue. You can find this in the night sky by eye. And, you know, I think it's also like the Subaru logo. Did I mention that? I feel like I mentioned that at one point, the Pleiades. In any case, they're very young, blue, hot stars that are producing a lot of light, and then their light is being scattered off of the surrounding nebula that is in that region. And so that's why we have a reflection nebula near the Pleiades. Okay, so here is in a nutshell all of these nebula put together. So you might have a dark nebula back here, right? And so if I were over here, maybe I wouldn't see what's going on this side, right? So if I were to the right of this dark nebula, I might not see what's going on over here. But that's the idea of a dark nebula. It's obscuring some of the light. But then as we get closer to what's actually happening here, where maybe I have star formation or young hot stars, then they're going to put off a lot of radiant energy, and then that can cause the surrounding gas to glow and produce an emission nebula. Okay? Then if I get a little farther away again, I might have another dusty cloud, which is, close enough that maybe it can scatter some of that light, and then I'm seeing more of a reflection phenomenon here with a reflection nebula. And so, oftentimes you might have all three of these things going on in a star forming region at once, depending on where you're looking within that region. Okay, so again, a lot of this relates to the stars that are nearby, or the stars that are being born. And so the interaction that can take place can be reflection, it can be emission if it's causing a glowing effect, or it can be obscuring the starlight like a dark nebula. So again, these are the pillars of creation. I guess they're sideways, okay? And you can, I don't know, I guess this is maybe just part of one of them zoomed in. So you can again see that taking place. You see the dark here, you see like the emission here, and I'm not sure, maybe you see a little bit of reflection in here as well. Okay, I don't actually know where this quote came from, I confess. But it's interesting, I guess. It's kind of giving you everything in a nutshell, what's happening. Okay, and again, the different colors are going to indicate different elements. The red is more of your hydrogen, the green is more of your oxygen, blue is more like sulfur. Okay, and so the emission nebula that we see, we can put this through a spectrograph and look for the actual lines, right? And that's how we're able to identify. Like here's H beta, but if we went over here to H alpha, this is our hydrogen that's producing a red color, because here's the wavelength here, and that corresponds to more of a reddish color. And then that green color we were seeing was more like oxygen, right? And sulfur isn't on here, but this one has an example of nitrogen on here at maybe also at a bluish color or greenish color. And so these oxygen lines that you're seeing, or emissions that you're seeing, are sometimes referred to as forbidden, but they're not actually forbidden, they're just rare. We can't really produce them in a lab very often, but in an emission nebula, you can see this greenish color due to a doubly ionized oxygen ion that is emitting in this hue. I don't know how to say this. Ophiuchus or something. I really don't know. But this is another nebula region where it's near Antares, which is a bright star. But you see here there's a reflection nebula. Here is more like a dust cloud, and maybe here's an emission region. So again, you're seeing like all three of those phenomena happening at once. Even though we discussed them in isolation, oftentimes a star-forming region is a large region, and so you have a lot of these things happening at the same time. Okay, so to try and get more of a handle on the composition of what these molecules actually are, we can use radio waves to detect things a little bit more clearly, and we've been able to show again that mostly these are made of hydrogen, which again is no surprise, but there are other molecules that are also present, such as CO is carbon monoxide. I don't really know all of these. Water, I feel like one is, who's a chemistry buff in here? ammonia. I feel like one of them is ammonia. Anybody know? I don't know. But those are some examples of other molecules that might be present. Formaldehyde, there we go. That was this one. Formaldehyde is another thing that you might see there. Here again is the Trifid Nebula. See the three spokes, so to speak. And they're able to detect a little bit of formaldehyde from the Trifid Nebula, or M20. And then again, looking in other wavelengths, we can add contours to this to kind of show where things are the most dense. And it seems like that formaldehyde is most dense over here. And because these contours are kind of overlaid, you see that they indicate sort of a swirling effect that's taking place here. It's rotating, in other words. Okay, so first clicker question. Let's see how we do. Okay, we're missing the other two today, right? So that's everybody. Okay, so let's see what you guys answered. Ooh, you're kind of split here. So some people were saying hydrogen and oxygen. Some people were saying reddening and scattering. A few people were saying helium and iron. So the correct answer should have been the oxygen, hydrogen and oxygen, D. So going back to, hold on. Going back to here is where we were talking about the Rosette Nebula, and we talked about the red being due to the H alpha, the hydrogen, and the green being due to the oxygen and the blue sulfur. Okay, here's another one for you. That was the next one, right? Yeah, okay. All right, are we all in? Okay, so looks like most of you said B, and that is the correct answer. When you have light actually going through, it's going to get dimmed and reddened. Those were the two effects that we talked about with the dark nebula, or with any kind of nebula in which the starlight can pass through in any way. Okay. Yeah, so the twinkling is really only an atmospheric effect here when we're looking through it on Earth. The blue wouldn't be due to light going through it. It would be, scattered light. And then the emission nebula, again, is not really light going through. It's glowing of its own accord there. Okay, so any questions on this stuff about interstellar media? Okay, so I think now is probably a good time to take our break, and then what we'll do is we will come back, let's just say 5 after 11. We'll come back and we're going to go further into detail on this chapter.